Solving combustion thermodynamics problems, part 1. We're going to do 3 homework problems, and I'm going to split them into 3 different videos to help you guys be able to find them quicker. However, for the first 2, this concept is really important. So let's say that I have a bag of cookies, and I eat that, and each cookie has 100 calories. And there's 1,000 calories in the bag. How many cookies did I eat? When I ask this in a lecture hall, I pretty much get a unanimous 10 cookies. So how did we do that? Well, we took the total calories per bag and we divided by the calories per cookie. When we did that, we got the amount of calories, or we got the amount of cookies. You can think about this a couple of different ways. You can actually do it with using dimensional analysis, or you can just use thinking about it. Either way works. But either way, this feels kind of easy. This is actually the exact same thing that's going to be dealt with in the first 2 of these problems. So take a moment and pause the video and read through this problem. Try to work on figuring it out if you can, using the concept that I just talked about. And if you can't, that's okay. Just read through it and then come back when you're done. All right, now let's take some things to consider here. So if we have the maximum number of balloons, that means that everything is going perfectly. So we can go ahead and assume that all the heat gets transferred, nothing gets transferred back out. We're doing perfect world stuff here. Let's also consider that combustion of a hydrocarbon is when we take a hydrocarbon and we react it with oxygen to form carbon dioxide and water. And so we can write this chemical reaction out. We also know what the volume of a sphere is. So since we know all of these sorts of things, let's make a plan. So we're going to take the kilograms of the hydrocarbon that's given. We can convert to moles using our molecular mass from the periodic table. So now, since we have the reaction and we can look up the delta H's of formation of everything, we can turn that into kilojoules of heat that's given off. Separately, we can think about what the volume of air is, and we have the volume of the sphere, so we know that. We can use the density, which is given, in order to convert that to mass of the air. And then we can use Q equals mc delta T to know how much it takes to heat one balloon. So now we're back to the cookie problem. If I know my total amount of heat and I know how much heat it takes to heat one thing, I can take my total over each one, and that's going to give me my number of balloons. So take a moment and work through this first part and see if you can convert your kilograms into moles first. And if you can move on, great. But go ahead and pause it and try to do this, and then come back when you need help. All right, let's convert my kilograms into moles. So first we'll convert kilograms into grams, then using our mass from the periodic table. So this is C3's mass, H8's mass, add it all up. We get our number of moles. All right, now let's write out our chemical reaction. So we'll react our hydrocarbon with oxygen to form carbon dioxide and water. Now this isn't balanced, so we need to make sure to balance it. We're going to have 3 carbons here, which gives us 3 here, 8 hydrogens here, which gives us a 4 out here to get 8 total. And then that's going to give us a total of 6 plus 4 oxygens. So that's 10 oxygens, so we need to put a 5 out here. From here, we can fill into DH of reaction. Do make sure that you grab the DH for gaseous water, otherwise it'll throw your numbers off. So we have 4 times water, 3 times carbon dioxide, minus 5 times oxygen, gives, and our 1 times our C3H8. From here, we type this into our calculator, being careful to remember that this negative applies to this entire thing to get our answer. So this is going to be our total heat that we have. Now, we need to adjust for one more thing. This would be our heat if we had 1 mole. Because out here is a 1, and here is per mole. But we don't have 1 mole, right? We have this many moles. So now we need to combine our DH with our number of moles. So now we can take our 2043 that we got per mole, we can multiply it by the number of moles that we had, To get our total overall, this is how much heat is given off. Great. Now we need to figure out how much heat does it take to heat one balloon. So we have our things to consider and we have our plan. This might be a good time to pause and try to do this on your own if you didn't originally and see if you can get it. And then come back when you're ready. All right, let's fill into our volume. I think the simplest way to do this is convert to meters before filling in, and then that's going to give you your meters cubed. You can do it after if you want, but this way is a little bit easier. So now, using our meters cubed, we can fill into Q equals MC delta T. I'm going to do this all in one big stretch to show you a shortcut, but there's a lot of times that people would probably take this first and convert to kilograms first, and that's totally fine, and then fill that mass in. So I'm going to fill into Q equals MC delta T, but I'm going to do it all in one big step. And so I'm spacing out my MC delta T so that you can see it. This is my M. So I took my 7.238, I multiplied by my density, right? Density is mass per volume, multiplied by my density. This right here would give me kilograms, but when we fill into this, we're comparing to grams. So I'm going to go ahead and put my conversion factor for grams in. Then for C, we're going to do 1.009 joules per gram degree Celsius. But at the end of the day, I'd probably rather kilojoules because my delta H is in kilojoules and that's going to be a more manageable number. And so I'm going to put my conversion factor for kilojoules in here. And then my delta T is 100 minus 25, so that's going to be 75. Now you plug this all into your calculator. Notice that this is going to cancel with this, so you don't have to plug that in if you don't want. And that's a nice little shortcut here. So this gives us 518 kilojoules per balloon. And now we're back to this step. So this would be another good pause point if you want to try to figure out from this, what's your total number of balloons. So from here, we have our kilojoules total. We have our kilojoules per balloon. We'll take our kilojoules over our kilojoules per balloon, and we'll get our 89 balloons.